Hello. I'm covering section 1.5. So that's a continuation of quadratic equations. This section is on applications and modeling with quadratic equations. The strategy is going to be the same as we use for linear models. We are going to set up an equation, in this case, a quadratic equation, to solve our problem. Okay, so I'm going to start with the following example. Let's suppose that the product of two consecutive even integers is 120. Let's say two consecutive positive even integers is 120. We are going to find the integers. So like we did with linear equations, from the question of the problem, we're going to set up a variable. We're going to let a variable represent what we want to find and write an equation. So let x be the smallest integer. So if we have two consecutive even integers, that's going to be x, and the next even integer is going to be x plus 2. So even numbers increase by 2. The product of these two is 120. So we're going to solve this equation for x. First, we need to write the equation in standard form. So x squared plus 2x equals 120. Or x squared plus 2x minus 120 is 0. So we can do this equation by factoring. We want two numbers whose product is negative 120 and whose sum is 2. And those are going to be 10. Okay, those are going to be plus 12 and minus 10. Okay, so we did the hardest part. So either x is negative 12 or x is 10. So when we're doing word problems with quadratic equations, we're going to have two solutions. Most of the time, we're going to discard one solution and keep the other one. Now the integers must be positive, so we are going to disregard the negative number. So that one we disregard this. And we have the rest. So x equals 10 is going to be the solution, and the integers are 10 and 12. So those are those are the two consecutive positive and even integers whose product is 120. So the integers are 10 and 12. The next positive even integer is 12. Okay, we're going to do more examples with geometry. And in the next example, we work with the area of a rectangle. You know the area of a rectangle. I'm not going to write it down. The area is length times width. And I also mentioned the volume of a rectangular box. So we're doing number 23. On page 130. Okay, a parking lot has a rectangular area of 40,000 square yards. The length is 200 yards more than twice the width. Find the dimensions of the lot. So that's page 130. We're going to use the area of a rectangle. We know from the information that the length is x more than twice the width. So let x be the width. And find the dimensions, we're going to find the length and the width. So if x is the width, the length is 200 yards more than twice the width. So that's going to be x plus 200. And the area is 40,000 square yards. So we know that the area is length times width, where the length is x plus 20 and the width is x. So A, the area is 40,000. We're going to solve for x. We're going to find two solutions, one that doesn't make sense. So we disregard the one that doesn't make sense and keep the positive solution. Okay, so let's solve the equation. So that's x squared plus 200x equals 40,000. That's another equation that can be done by factoring. We're looking for two numbers whose product is negative 40,000 and whose sum is 200. The number, let's see. Yeah, the numbers. Okay, I'm missing something. It says, okay, 200 yards more than twice the width. I'm missing a 2 because twice the width is going to be 2x. Yeah, so I was missing a 2. And let's fix this. So this is 2x plus 200. Okay, let's write this better. And when we distribute, we have 2x squared and then 2x squared plus 200x minus 40,000. Yeah, I was missing the twice part. Divide everything by 2. Everything is divisible by 2, so we can simplify this equation a little bit. So we have an equation that is easier to work, a little bit easier to work with. And that's x squared plus 100x minus 20,000. So that's something we can do by factoring. When the leading coefficient is 1, the first terms are going to be x and x. And we want two numbers whose product is negative 20,000 and whose sum is 100. The numbers are going to be 200 and negative 100. So the solutions of this equation are going to be negative 200 and 100. But negative 200, this is negative. We want to find the dimensions of a parking lot, and dimensions cannot be negative. So we must keep the positive solution. So that's going to be the solution. And that's it. The width is 100. So the width, I'm going to write in the space. The width is 100 yards. And the length it's 200 yards plus twice the width. So that's going to be 2 times 100 plus 200. And that is 400 yards. Okay, so the length is 400 yards and the width is 100 yards. Okay, we're going to do the next example with the volume of a rectangular box. That's going to be the next formula. The volume of a rectangular box. I mentioned this in the last section, or not in the last section, in the section with linear models. So if we have a rectangular box with a given length, width, and height, the volume is length times width times height. So number 27 involves this formula. That's still on page 130. Okay, a rectangular piece of metal is 10 inches, longer than it is wide. Squares with sides 2 inches long are cut from the four corners, and the flaps are folded upward to form an open box. If the volume of the box is 832 cubic inches, what were the original dimensions of the piece of metal? So let's see where we are. We have a rectangular piece of metal that is 10 inches longer than it is wide. So X is the width of the original piece of metal. And it is 10 inches longer than it is wide. So we know that. We also know that square with inches or squares with sides 2 inches long are cut from the four corners and the flaps are folded upward to form an open box. Okay, so squares with sides 2 inches are cut. So the dimensions of the new box are going to be X minus 2 minus 2. That's going to be X plus 6. That we have now, we cut squares with 2 inches, and then the width of the box is going to be X minus 2 minus 2. So that's going to be X minus 4. So we're forming a box, an open box. That box will have dimensions so that's an open box. And that box will have dimensions 2, x plus 10, and x minus 4. Okay, so the volume of the box is 832 cubic inches. So now we know that length times width times height, so that's 2 times x minus 4 times x plus 10 is equal to 832. We are going to solve for x. Okay, so we can simplify this equation a little bit by dividing by 2. So x minus 4 times x plus 10 is 832 over 2, or 400 over 2, or 416. So x minus 4 times x plus 10, that's going to be x squared, plus let's see. Okay, I missed something. Yeah, this was x plus 6. So I'm making a mistake. Okay, so the x. Okay, let me. I'll need to close this board, this whiteboard, and share it again. Okay, so let's try again. Okay, but I was making a mistake because the dimensions were the dimensions of the box were x plus 6 and x minus 4. Okay, and also we need to correct that. Okay, so that's x plus 6 and x plus 6. So that's going to be, again, x squared plus 2x equals 416. So that's something we can do by plus 24. Oh, sorry, minus 24. I'm missing minus 24. Equals 416. Okay, so subtract 416 from both sides. So x squared plus 2x minus 440 equals 0. So that's something we can do by factor. We want two numbers whose product is 2, whose product is minus 440 and whose sum is 2. Those are going to be plus 22 and minus 20. And we're almost there. The solutions of that equation, okay, or we have that x is either negative 22 or x equal to 20. But like before, we need to keep the positive solution because this one doesn't make sense. So let's look back. We know that x is the width. And so the width is x. And the length is 30. Okay, so we're going to answer the question with a full statement. The box, or not the box, the original piece of metal was 20 inches wide or 30 inches long and 20 inches wide. Okay, now do one more example with geometry. This one involves the Pythagorean theorem. So I'm copying the statement. Okay, this is from page 125. Okay, in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. That is, if the legs both measure A and B, and the hypotenuse, the length of the hypotenuse is C, then A squared plus B squared equals C squared. We're going to use this to answer the following, to solve the following problem. That's number 36 on page 131. Okay, Grady is flying a kite on 50 feet of string. His vertical distance from his hand is 10 feet more than his horizontal distance from his hand. Assuming that the string is being held 5 feet above ground level, find its horizontal distance from Grady and its vertical distance from the ground. So nicely, they already set up the triangle for you. Okay, you can see that he has 50 feet of string. Then his hand is 5 feet above the ground. And we have more information that the vertical distance from his hand, if the vertical distance from his hand is X, the vertical distance from the hand to the kite, or the horizontal distance from the hand to the kite is X, the vertical distance is going to be X plus 10. Okay, so X is the horizontal distance. The Pythagorean theorem says that X squared plus X plus 10 squared is equal to 50 squared. Okay, we're going to solve this equation for X. First, we need to square X plus 10 and 50. So that's X squared plus X squared plus 20X plus 100 is equal to 2,500. Okay, so X squared plus X squared is 2X squared. And 100 minus 2,500 is going to be minus 2,400. divide everything by 2. So 2x squared over 2 is x squared. 20 over 2 is 10. And 2,400 over 2 is 1,200. So we can solve this equation for x. These factors as x and x. And then we want two numbers whose product is minus 1,200 and whose sum is 10. Those numbers are going to be 100. Those numbers are going to be 30 and 40. So that's going to be plus 40 and minus 30. So either x is negative 40 or x is 30. But we need to keep the positive solution because we're talking about lengths and dimensions. So length cannot be a negative number. So the horizontal distance from Grady's hand to the kite is 30 feet. And the vertical distance. Okay, so the vertical distance, we know that the string is being held 5 feet above the ground level. So that's going to be 5 plus x plus 10. So the horizontal distance is that, and the vertical distance is 45 feet. It's 45 feet because that's going to be 30 plus 10 plus 5. We had this triangle with dimensions x and x plus 10, but also Grady's hand was 5 feet above ground level. So this distance was already 5 feet. So that's where the 45 is coming from. Well, that looks like a 15. Let's see what I can do. Okay, I'm just going to do it like this. I'm just going to write a brace and indicate the 5. Okay, so the vertical distance is 45 feet. So far we have been able to factor we have been able to solve every equation by factoring. We're going to do one that requires the quadratic formula. So that's number 54 on page 134. So that one we'll need to do it by factoring. By the way, this is not the situation of right now because that's a 4-year private college. But that's just an exercise. The average cost in dollars for tuition and fees for in-state students at 4-year public colleges over the period 2000 to 2014 can be modeled by the equation below, where x equals 0 corresponds to 2000, x equals 1 corresponds to 2001, and so on. Based on this model, for what year after 2000 was the average cost? 8,605. Okay. So we have this this equation where x is the years since 2000. And we want to know when the average cost was 8,605. So we are going to solve the quadratic equation 4.065 x squared plus 370.1x plus 3,450 equals 8,605 for x. That one I will not be able to factor. Let's first subtract 8,605 from 3,450. Okay, so we have 4.065 x squared plus 370.1 x minus 3450 minus 8605 is 5155. And we have no choice but to use the quadratic formula. Okay, so x is going to be the opposite of 370.5 plus minus the square root of 370.1 squared minus 4 times a times c. Divided by 2 times a. Okay, so all this product is going to be 220,794.31. So this is minus 370.1 plus minus the square root. All this product is going to be that. 220,794.31. All this divided by 8.13. So we have two possible solutions. Okay, so possible solutions. Okay, the first one is x equals minus 370.1 minus the square root of all that. Okay, so it's not hard to see we have a minus and minus. So this solution is going to be negative. So we can disregard that. So this is not a solution because x represents years after 2000. I mean, we can try to approximate and all that, but yeah, but there's no need to do that. This is not a solution because x represents years after 2000 and not before. So a negative solution would be years before, but that's not what the equation models. And the other solution is x equals minus 370.1 plus the square root of 220,794.31 over 8.13. Okay, so we'll verify what the solution looks like. Okay, so this is what this is 370.1. The opposite of that, and then plus the square root of 220,794.31, and all that divided by 8.13. So that's about 12.3. So this is approximately 12.3, and that corresponds to 2012. So the question that is that in 2012, that's years after 2000, and they were asking us for the tuition, I believe, tuition and fees. The tuition and fees, or the average cost, was 8605. Thank you for listening.